Good evening, everyone. In our last video, I think we are discussing about delete operation, how we can able to delete the elements. Okay, so how you can able to delete the elements present in a binary search tree. I think we are discussing. So in this, how many cases are there, sir? We have three cases are there. Case one we discussed already. So what is the meaning of this case one? If you don't have any child nodes, that means if you don't have any children, then how we can able to delete the nodes, we have seen very clearly. And the second case, if a node is having only one child, then how you can able to delete the node also, we have seen very clearly in our last videos. Okay, so for this, which tree we have considered? I think first root node is nothing but a 10. Root node is nothing but a 10. So for this, we created a left subtree as a 5, right subtree as a 15. Left subtree is nothing but a 5 and the right subtree is nothing but 15. Like this we have. So next again for this 5, so left subtree will become 3, right subtree will become 7, left subtree will become 3 and right subtree will become 7. Like this we have. So next and after that, root left node, root left node, this is the root node. Left node is nothing but this one, so its left field is a 3. Okay, so root node 3 7, where 6 is coming, root left, root left, left to right, right to left, 6 we are getting here. Next and after that, so root right is there, right? For this, left is nothing but a 12, right is nothing but a 17. Like this we created, it is a 12 and this one will become 17. Okay, right? Next and after that, root right node is there, right? Its right node is there. For this, left is nothing but a 16 and for this, right is nothing but 18. Like this we have. So here deletion of leaf nodes is very easy task because simply we have to delete these references. That's all, right? Simply we have to delete these references. This is nothing but how you can able to delete leaf nodes. Already we have written code for that. So if any node left child is equal to null and right child is equal to null, means that particular node we are going to delete. Simply it will return null. Suppose if you have only one child, then how you can able to delete? For example, consider I want to delete 7, sir. How you can able to do this? What is the first step? We are going to pass a root node. Here root node is nothing but a 10. This root node we are passing, which is nothing but a node, and the data which we want to delete is nothing but a 7. Is first we have to do search operation. Node dot data, root node data is a 10. Is it less than 7? Condition is not satisfied. Now we are checking, is it greater than 7? Yes, condition satisfied. So then I am going to search for deletion of node dot left. We are going to call node dot left, which is nothing but a 5. Now node will become 5. So it is going to call one more time, node dot data is 5 is less than 7. Okay, condition satisfied. If the condition is satisfied, node dot right will become this one. This will become node. Sir, what is the node dot data? Sir, 7. Is it less than 7? Condition is false. 7. Is it greater than 7? Condition is false. So what will happen? Else part. So the node what we have here is 7. 7 is nothing but my node, right? Is its left field is equal to null? No. Okay, and since and so other condition is not satisfied. Else if node dot left is equal to null, no, it is not equal to null. Node dot right is equal to null, yes, right is equal to null. Then what we are going to return? Node dot left. That means this particular reference will come here. So see, have you observed which one we are calling? delete of maybe in this case node dot right. So when we are having this node, it's a right field we are passing, it's a right field we are passing, okay, with node dot right comma value. And what value we have written? Node. Which node we have written? This particular node, right? What is this node? Node dot left. This node I am assigning to node dot right. Here node is there, its a right field will become this one. Like this we are going to delete this particular node, sir. So this is the node when we have to use this kind of deletion, when your node is having only one child. Of course, I think we explained very clearly in the last video, but just the execution part also we have seen. Okay, now let us execute this code and check really, so that node 7 got deleted or not, we need to cross check. Now you can see in order at very beginning 7 is there. So next in order that 7 is not there. Okay, this is nothing but how you can able to delete a node which is having one child. Okay, now I want to delete a node with two children. I want to delete a node with two children. Sir, let us see what will happen. Consider I want to delete here. So 17th node I want to delete. It is having two children. Sir, first term we are going to call this node dot data. So node dot, so the node which you want to delete is 17. So initially node will be there here. So we are going to check is 10 is less than 17. Is this condition is satisfied or not? Okay, so node dot data, node is nothing but a 10. Is it less than the value? Yes, condition satisfied. So then what will happen? Delete of, we are calling this for node dot right. Node dot right will become this one. So this node will be now node. Okay, node dot right. Sir, value is nothing but a 17. Here check the condition. Is 15 is less than 17? Condition satisfied. Now this value we are going to find out. This will become node. You can check here 17 less than 17, condition not satisfied. 17 greater than 17, condition not satisfied. So both the conditions are not satisfied, came to else. Sir, case 1, the node which you are pointing, that is 17, is left child and right child, both are null? No. So that means this condition not satisfied. Is left alone null? No. Is right alone null? No. Then directly we can execute code here. If all these conditions are not satisfied, means what? Directly we are going to execute. Sir, here we need to find out in order successor for this is node I am calculating, which is nothing but in order successor. So find in order successor node dot right. So why we are giving right? Because if you want to delete this node, which node will become root node? 18. Because in the tree output you can see after 17 which value we are getting? 18. If you take any node, okay, if you take any node, for example like this, if you have some nodes, okay, if you have some nodes like this, sir, if you want to find out in order successor for any node, it will be there in that in order which will be available in the right tree. Okay, if you want to find out in order successor for this, it will be in order successor. If you want to find in order successor for this, it will be this one. If you want to find in order successor for this, it will be right this. Because after this node only this node will come. So that principle I am applying here. For that I am going to write a logic. So what is that problem here? In order successor of node dot write. Let me write that method static. Okay, so static, my return type is nothing but node find in order successor of. Here I am going to take a node. How to find out? How to find out in order successor? Very simple, the last element, right? So I'm not talking about every node. We can't find out every node in order successor. So for this right subtree, I want in order, next order. So after 15, next order immediately I want. Then what we have to go for? So we need to keep on searching for until left node. Until left node last value will become in order successor. So in this case, what will happen? 18 will become in-order successor. Okay, now what we have to do? So while that node left field is not equal to null, that node left field is not equal to null, you have to take a node will become node dot left. So finally we have to return the node. Now observe carefully. Here we have to find out in order successor for what nodes are 17. Okay. So we have to find out in order successor for this 17. Now how you can able to find out? So node dot left is not equal to null. It's left node. Is it not equal to null? Yes. Then node will become node dot left. Now this will become node. Okay. Sir, node dot left is not equal to null. Yes, it is not equal to null. Then it is equal to null. Then we have to return this node. Sir, is it correct? Yesterday also we got confusion with this. Node dot right, I think in order successor after 17, which should become in order successor 18, right? So that means here, yeah, we passed node dot right? So here, what is the node? This one. So this subtree we are passing. Okay, this subtree we are passing. For this, we are going to search for left subtree. Are you getting my point? No. Node dot right we are passing. So what is the node dot right? This is the node. Its right node is nothing but 18. Okay, its right node is nothing but 18. So now what will happen? That 18 node is going to pass as a input. Is 18th left node is equal to null? Yes, here 18th left node is not there. So what will happen? It is going to return the node itself. Which node will be returned? 18. Suppose if it is having its left node, consider just for your example sake I'm taking. So here we have some 17.5 is there means. So what is the in order for this tree? Have you observed 16? Then root node, then again a tree. So in this left node will become 17.5 and then 18. So what is the in order successor for 17? 17.5. Are you getting my point? Sir, everyone got the clarity about this logic? Please confirm everyone. Please confirm everyone, because we are passing which value? Node dot right node we are passing. So for that we are finding left value. Clear? Leftmost node. Right. Sir, after this, what activity we have to do? Sir, I searched for the data and I got that data. Now, node dot data will become in order successor dot data. Which node we are trying to delete? 17, right? Which node we are trying to delete? 17, right? So its data will become is dot data, which is is here. So we got is as 18, right? So this data, what is that data? 18. We assigned this one as 18. Now we are going to perform delete operation of this is, because we changed the content. Now this is by default we have to delete. How to delete? Very simple, sir. Your node right field is there, right? Try to delete. Try to delete by passing node dot right comma in order successor dot data. Sir, already this node we assigned, so no problem. Now I want to delete this node right field, so which is having in order successor data. What is that? 18. So this is the node, right? Is it having left child and right child? No, immediately it is going to assign null. So it is going to assign with null. So immediately it is going to assign null, like this we have. Okay. I think you people got very clear clarity about this. This is nothing but a third case. What we are doing in third case, sir, I'm explaining the diagram. Observe carefully. Suppose if I have a node called X here, and if I have a node called A here, and for this, if I have a node called B, and for this, if I have a right child called C, just for example sake, assume I want to delete this particular node. So this node is having two children, right? So what we are going to do here, This will become your main node. Sir, now I am searching for in order successor. Find in order successor of node dot write. I am sending this entire tree as an argument. Okay, node dot write means this particular thing will become node now. Now, node dot find in order successor is node left is not equal to null. Yes, it is not equal to null. Now node will become this one. So repeat, is node dot left is not equal to null? No, it is left is equal to null. Return node. Now this value will become in order successor. Node dot data. This is our main node, right? Node dot data will become is dot data. What is is dot data? B. So now this is not X. This is nothing but a B. Okay. Now we have to delete this B, right? For this, what activity I am doing? Sir, node dot write. This is the node. Its right field is nothing but this one. I am sending this the right field is dot data. That is nothing but a B I want to delete. Now again the same function it is going to call. Sir, it will move to this left subtree. So B is there. So here node will be pointing. Is it having left child? No. Is it having right child? No. Then this value will be deleted. Directly it will be returned with null. So that automatically the value is moved to the top, sir. This is the way how you can able to perform this activity. So let me take executable code, sir. We need to get clarity once if I execute. Sir, is the node 17, is it removed from this list or not? We need to cross check. I think here we have not passed the value as a 17. Let me cross check. You can see the node 17 got deleted. This is the way how we can able to perform delete operations, sir. Everyone, can you please confirm, is the concept is clear for you people? Please confirm, sir. I think how we can able to delete, you people got a clarity. Please confirm everyone. So if node 18 also have a child like 17.5, yeah, that's what I told, right? If 18 is having a child, then 17.5 will become root node. Got it? So in this tree, we have 10 is there. So 5 is there and 3 is there and here 7 is there and here 6 is there. So for this, we have 15 is there. For this, 12 is there. So for this, we have 17 is there. And for this, we have 16 is there and 18. Everyone, can you please confirm? Suppose consider I want to delete this node called 10. Which will become root node? Everyone, can you please confirm? Which will become root node? Please confirm everyone. I request everyone to please respond. Ahmad, Saqib Ahmad, can you please tell? Who is that telling 7? Swapnil, why 7 will come? What is the in order successor for this? So 3 and then 5 and then 6 and then 7 and then 10 and then 12 and then 15 and then 16 and then 17 and then 18. So what is the in order successor for 10? 12. 12 will come into the root. Are you getting? Yes. Now 12 will become root node. Now I want to delete 12 in this right field. So is it having any child? No, then automatically it will be removed. Suppose if it is having child, what will happen? If it is having only one child, then that will become parent. Suppose for 12, if we have 11, what will happen? 11 will become root node. Okay, are you getting? So like that, it will be having, sir. Okay. Right. So now what is the next one? What is the next algorithm in this binary search tree that I'm going to take here is all the delete operations we performed successfully here. So next operation is nothing but I want to remove all leaf nodes. I want to remove all leaf nodes from binary search tree. I have a binary search tree is there. My requirement is nothing but I want to remove all the leaf nodes. Okay, I want to remove all the leaf nodes. How we can able to remove? Yes, for that we have to write the code. I think let it be this one. Okay, let it be this one. Now, okay, keep these functions as it is. I want to define one more function. Static node leaf delete like this I am taking. So node, I have a node like this. So I will reconstruct a tree, sir. I don't want these many nodes. A simple tree I want to draw. So my tree is nothing but 4 is the root node. So 2 is nothing but a left child. This is nothing but a root node. Left child will become 2. For this left child is nothing but 1. Right child will become 3. For this right child is nothing but 6. For this left child is 5. For this right child is nothing but 7. Like this we have. Now, so how to draw this? Create a node called 5. So node left is nothing but 2. Node right is nothing but 6. So left will become 1. Left right will become 3. Root right is there, right? That is nothing but 6. Its left will become 5. Its right will become 7. That's all. So what will be the in order successor for these? 1, 2, 3, 4, 5, 6, 7. That's all right. Now I want to delete all the leaf nodes. So BST dot, so leaf delete. Okay, where I am going to pass a root node. In this root node, I want to delete all the leaf nodes. So if you delete all the leaf nodes, then what will happen? We are going to remove this particular one, this 3, this 5, and then this 7. Then what will be in order value? I think 2, 4, 6. That's all right. Now we need to implement that. How you can able to do this? It is very simple, sir. Suppose if your node is equal to null, then return null. Otherwise, if your node dot left is double equal to null and node dot right is double equal to null, then also return null. This is the main logic. Then node dot left will become, so delete leaf node in node dot left. Node dot right will become, so leaf delete of, I'm going to call node dot right. And finally, we have to return the node. Sir, consider initially my node is nothing but 4. Is it null? No. Is it left child is null? No. Is it right child is null? No. Then node dot left. Take this one. Okay. Sir, is this node is null? No. Its left child is null? No. Its right child is null? No. Because as of now, we, sorry. Yeah. Sir, is its left child is null? No. Is its right child is null? No. Then we are passing left. This will become node. Leaf node of delete of node dot left. Sir, now is node is equal to null? No. Is its left child is null? Yes. Is its right child is null? Yes. Then while calling this left child, we called this leaf dot delete, which is returning null. So this value will be assigned to null. Okay. Now this second node is there, right? For this, I am calling right child. So it is called, and easy term, this one will become node. Sir, its left child is null, right child is null. Then I'm going to return null, which will be assigned to right. So its right child also will become null. In the same case for this one. Now what will happen? All the nodes got deleted or not? Whenever you got a node, its left child, right child, both are null. Then I'm going to return this logic. Now let us execute this. You can see here 1, 2, 3, 4, 5, 6, 7 is the in order. But after deleting all the nodes, leaf nodes, 2, 4, 6 is nothing but in order. This is the way how to delete leaf nodes from this tree. How to delete all the leaf nodes from the tree. I think you people got very clear clarity, sir. Can you please confirm any doubts up to this? Please confirm everyone. Is the concept is clear for you people? Right, sir. So next one, what we have here is, sir, print in range. Print in range. Sir, I need to print the list of nodes. So whose values are in between. So K1 and K2. It is a problem, sir, which was asked in some interview questions. I need to print a list of nodes whose values are in between K1 and K2. We have two nodes are there like a K1 and a K2. I need to print out the list of integers in between this. So for this, I'm going to write the program. I think this leaf node concept is not required here. I will remove this. For this, I want to create a function. Okay, what is that function? Is nothing but a static void. So print in range function I'm taking, where I'm going to pass a node and then integer k1 value, integer k2 value. Like this, I'm going to pass. Now, what is my requirement? I have to print the values in between this. Suppose if your node is equal to null, then we have to return empty. So if node.data is greater than or equal to k1 and your node.data is it less than or equal to k2. In between this, if you have, we have to print the task. We have to do the task. Okay. Then how you can able to do? Parallelly, we have to take one diagram for this. I will take a new tree here for this purpose. Let us consider the root node is nothing but 8. So what is the left subtree for this is I am taking 5. Right subtree for this is nothing but I am taking 10. For this left subtree is nothing but 3. Right subtree is nothing but 6. For this left subtree is nothing but 1. Right subtree is nothing but 4. And for this 10, right subtree is nothing but 11. For this right subtree is nothing but 4. Like this we have. Sir, now if you take in order traversal of this one, which will become, so 1, 3, 4, 5, 6, 8, so 10, 11, and then 14. I'm giving K1 value as a 5 and K2 value as a 12. So what output I'm expecting? What are the values in between these? I think these values, right? I need to get output as a 5, 6, 8, 10, and then 11. Okay. How we are going to do this? Sir, first I have taken if node is equal to null, return. If node dot data, this is my node, right? Its data is greater than or equal to 5 or not, I am checking. Yes, condition satisfied. Now, node dot data 8, is it less than or equal to K2? Yes, condition satisfied. Condition satisfied. Then what we have to do? If the condition is satisfied, then we need to do two operations. Print in the range of node dot left, comma, so K1, comma, K2. And then SOP, system dot out dot, so print of, so current node data is in the range, right? That's why I'm printing that. And after that, you have to check in right part also, because the data is existed in the right part. Like this I'm taking. So what will happen? It will print this data. That is nothing but 8 will be printed. Okay. But before printing 8, what we are doing here? We are going to transfer the control. Sir, 1 second, please wait. Yeah, sorry, sir. There was some emergency phone call. Sorry for the delay. So now, what we are doing here, sir, can you please confirm? Am I audible? Sir, am I audible? Yeah, right. Yeah, it is something like in order success, in order traversals only. So this element is within this range. So what will happen? We have to move to the left. How you can able to move to the left? I'm going to call this one recursively. Now, is the data K1 and K2 is in between this? Sir, is the node 5 is there in between this 8 and 5 and 12? Yes. Then again, it will move to this. Sir, is this data is in between 5 and 12? No, right? Okay, no. Then it will come out from this one. Okay. And here we have to write one more condition. Else if what we have to do? So we need to check is the node no, not this one second. So here this condition is not satisfied. If this condition is not satisfied, what will happen? Node, it will print node data data. What is the node data data? 5, right? 5 will be printed. So now after this, what we are doing, it's a right field we are going to check. Is this right node? Is it in this particular range? Yes. Okay. Then again it is going to call. Same method. Again it is going to call. Sir, what about its left child? We don't have any left child. We don't have any right child. So it will print that particular data. Sir, now this data is also going to print. And sir, we have this particular traverses completed, right? Root node data it is going to print. What is that node? Sorry, what is that root node data? 8. Then same logic is applied for right node also. Is the right node is in between this 5 and 12? Yes. Okay, it is in between this. Then what will happen? Is there any left node for this? No. Then is there any right node for this? Yes. While moving to the right node, it will print that particular data. So it will print that 10 and it will move to the right. Sir, is this data is in between 5 and 12? Yes. So it will call for left. Is there any left node? No. Then what will happen? It will return. Then it will print the current node data, which is nothing but 11. Then it will transfer the control to this node. Is this node is in between these values? No. It will come out from this if condition. That's all. This is one case. Suppose if I'm giving the value like sir, k1 is equal to something like 3 and k2 is equal to something like 6, then what will happen? These both values are present only in the left subtree, not in the right subtree. So if root node is in between this, then this is the process. If root node is not in this process, then same operation only we are going to do. If node dot data is it less than k1, we are going to check. Definitely it won't be greater than k1. If it is less than k1, then we have to do this process in the left side. Then we will call same range function by passing node dot left comma k1 comma k2. Like this we are going to call. Suppose if it is not there in the left part, if it is there in the right part, then what we have to do? We need to call this print in range by passing node dot right comma so k1 comma k2. Like this we have to pass. So this is nothing but what we have, how you can able to print the values within the range. Now I want to do this. Sir, what are the nodes here we have? What is a root node? I think 8, right? Left subtree will become 5 and the right subtree will become 10. Then its left node, its left node will become 3. Its left right node will become 6. Then uh, so root left to left, root left. So obj dot root its left to left. So will become new node of which node we have to take? 1. And the same step we have to do it for right. Then what we have to do? So we need to do it for 4. Right. So right node we have to take, right? Right node already we have taken. Root dot right already we have taken. Its node is nothing but a 10. I think for this right we have to take, which is nothing but a new node of 11. And the same thing I want to take for 14. So it is again right node, right? Like this we have. Sir, now first I am going to print in order successor for both, sorry, in order traversals for both nodes. Let us see what will happen. Now you can see this is nothing but in order what we have for this. Now I need the values in between the range. Okay, how you can able to print that? Just I am calling obj dot, so print in range, print in range. So obj dot I am passing root node, and what are the values, sir? Here we have, I think 5 comma 12. In between this, is there any nodes? What output I am expecting? 5 6 8 10 11. These values I am expecting. Let me check, is these values are there or not? Sir, 5 6 8 10 11. This is nothing but how to print the values in between the range. In some interview questions, even they have asked some of these nodes values also. Then just you need to declare some variable. Instead of printing, you need to calculate a sum, sir. Okay, I think you can do that task by yourself. Can you please confirm, is this algorithm and its a concept, is it clear for you people? Please confirm, everyone. Is it clear for everyone? Please confirm. Right. Sir, last what you can call last topic in this binary search tree I'm taking, which is nothing but root to leaf nodes, root to leaf node path, root to leaf node path we have to calculate. So how you can able to calculate root to leaf node path? Let us see how it will be. Okay. Um, sir, for example, I am taking this tree. What are the paths that we are going to get? Sir, how many paths are there? Root to leaf node, we have to calculate paths. So 8, 5, so 3, 1, and then null. This is one path. So 8, 5, so 3, 4, null. This is another path. So 8, 5, 6, null. This is another path. So 8, 10, 11, 14, null. This is another path. These are the 4 paths which are existed from root to leaf. This one I want to calculate. So it is a kind of list, right? It is a kind of list. That's why we have to go for a new method by using array list concept. So static, the method name is nothing but void print root to, okay, root to leaf. Like this I am taking, where node I am taking, and I am taking array list. It is going to hold integer objects. Consider the array list name that I am taking as a path. Okay. So whatever the node has no children should return 1 as will be considered as a path, right? Yes, up to leaf node. So until its value is not equal to null, you need to traverse. Okay, I will show you, don't worry. Now listen carefully how I can able to do this. Sir, if your node is equal to null, then simply I'm going to return. Otherwise, path is the array list. Add method is there, right, in array list. So node dot data I am adding. So in my path, this is my array list. This is my array list. I want to add h because it is the root node. Now after this, what I am doing, I will check array. If your node dot left child is equal to null, and your node dot right child is equal to null. Then I want to print path. So I will send this array list. Of course, it is a utility method. So static void. So print path I am taking. So which is taking array list. So integer. So path as argument, and for integer I is equal to 0, I less than path dot size I plus plus. So what we have to do? System dot out dot print of path dot get I. In that I position, which value is there, it will return, and followed by some arrow mark. At last, system dot out dot println of I am printing null. Like this we have, right? So next and after that, sir, what will happen here? First we got 8. Sir, is its left node is equal to null? No. Is it right node is equal to null? No. This condition is not satisfied. Then what we have to do? Sir, print path of, I am going to call node dot left subtree. Okay, no, not to print path, sorry. So print root to path. Okay, root to leaf. Print root to leaf. So node dot left subtree I am passing, and then path I am giving. And print root to leaf node dot right I am passing, and then path. Listen carefully here, a bit tricky concept is there. Now, sir, 8 got inserted. This condition not satisfied. Now I am passing left subtree. Sir, what is the left subtree to this? 5. This will become node, root node now. Now, is it equal to null? No. Add node dot data. What is the data? 5 will be added. Then, is its left child is null? No. Is its right child is null? No. Then print root dot leaf of again node dot left. Its left child we are passing. So 3, it will become root. So try to add that. Is its left child and right child are null? No. Then take this one. So 1. Sir, is its left child and right child is null? Yes, left child is null, right child is null. Try to print this path. We have to print this one because automatically it will go here. And one more back will come. Node dot right. Okay, node dot right. So before moving to this node dot right, this is the node right. Before moving to this node dot right, we have to remove this node or not? Yes. While coming out from this, I'm going to remove path dot. There is one method is there called remove. Which value we have to remove? In the list, last element we have to remove. Sir, how to find out last element? Path dot size is there, right? -1. Its index value it is going to pop. Sir, in this, what is the length? 0, 1, 2, 3. So total length is 4. 4 minus 1 means 3. In third location, which value is there? That will be removed. Then the same operation will be performed for this one. So 4 will be added. Sir, its leaf nodes are empty. So it will print this path. Then 4 will be removed. Again, one step backward. Then 3 will be removed. Then 6 will be considered. So it will print 8, 5, 6. Then 6 will be removed. One more step backward. 5 will be removed. For this, left subtree is not there. Right subtree is there. It will insert 10. Then it will insert 11. Then it will insert 14. So it will print that. So again, one step back. So no nodes are there. One step back. Again, no nodes are there. One more step back. No nodes are there. Okay. So next, one more step back. So total nodes got completed, right? So it will automatically terminate. Okay. So this is nothing but what we have here. Though there is no recursion for both nodes are null means. So this is the way how you can able to print. But let me check really, is it working or not? We have to cross check. So here I'm going to pass. So obj dot, so print root to leaf. Okay, by passing obj dot root node, and even we have to pass a array list object also. So new array list of to hold integer objects. Like this I'm going to pass. Let us check. Anyway, util package is already imported, right? Now you can see, sir, is it printing all the paths or not? Yes. So from root node to leaf node, what are the paths which are existed? It is going to print all the paths. This is the way how you can able to find. Sir, can you please confirm up to this? Do you have any doubts, friends? Please confirm. Clear? I request everyone to please respond. Is the concept is clear for you people? Right, sir. So that's all about these binary search trees. With this binary search trees got completed, tomorrow I will try to start AVL trees and then red black trees. Okay. And then priority queues, graphs, time and space complexities. Okay. And this weekend, greedy algorithms and divide and conquer one session, backtracking and dynamic programming another session. Okay, Saturday and Sunday. So max these topics will be finished Saturday and Sunday. These topics, so depends on the examples we are going to see. AVL trees, red black trees. So minimum it will take some 2 to 3 days. And then priority queues, graphs is required minimum 3 to 4 days, and then time complexity is 1 or 2 days, maximum another 1 week. Okay, so maybe next week end we are going to wind up. Okay, if any missing topics are there, I need to recollect and I need to check. If any missing topic is there, definitely I will. And one more thing, I'm going to add a few more topics and a few more examples. So if such type of topics are added, I will inform you. I'm going to take seminars for those topics. In that you can also attend. Okay, right. I will upload these running notes within a few minutes. You can able to download. Thank you, sir. Good night.